Hey everyone, and welcome to today's Explainer. I'm so thrilled to have you here because today we're going to completely demystify something that, well, you probably use every single minute of your waking life but might not fully understand. We're talking about the internet. We're going to strip away the magic and look at the actual history and the raw mechanics behind it. By the end of this, you're going to understand how millions of physical networks actually connect us, forming one massive, globally distributed system. It really is a giant network, and it's fascinating. Okay, let's dive into this. Here is our roadmap for the explainer. We'll start with the birth of the network, move into network connections, then communication models, internet addressing, and finally wrap up with cyber ethics. Section 1. Birth of the giant network. How it all began. To really get this, I need you to mentally strip away all the modern complexities of the web you use every day, right? So no social media, no streaming video, no sleek smartphones. We have to go back in time to understand what this thing actually is at its core. At its simplest, the internet is exactly what its name suggests. It's literally an acronym for an interconnected network. It's a giant wide area network. It's not some magical cloud floating up in the sky. It is an arbitrary, purely physical collection of networks interconnected by routers to provide packet delivery services from one host to another. Think of it as this globally distributed network of networks, physically linking millions of private, public, business, and government systems. Now, you might be wondering, why go through all the trouble of wiring the entire planet together in the first place? It's fascinating because the original motivation behind the internet was incredibly practical and honestly surprisingly simple. It was just to share resources. Early computers were massive, they were ridiculously expensive, and they were rare. Researchers desperately needed a way to share the computing power and the data of those few machines without having to literally be in the same physical room. And that deep, fundamental need to share, that is the DNA of our modern internet. And man, that simple motivation sparked a rapid, explosive history. It all kicks off back in 1969 with the ARPANET project, which was funded by the Department of Defense. This was the absolute seed of the giant network. From there, the evolution is just staggering. In the 1970s, we see the development of essential protocols like TCP/IP and FTP. Fast forward to 1990, and the World Wide Web is born, completely transforming this clunky academic network into a public, highly visual space. Then, boom, the mid-90s brings us Yahoo, Amazon, and eBay. The 2000s usher in Google, Wikipedia, Facebook, and YouTube. Literally, in just a few decades, we went from a handful of military computers passing basic text to a dynamic visual web that dominates global culture. Section 2. Types of network connections. Scaling up. But how does a system go from a single room to covering the entire Earth? Well, depending on the geographical area they cover, networks are classified into different scales. Because remember, this giant network is actually just millions of smaller, highly specific networks stitched together. First up, you have your LAN, or local area network. This is the small scale. Think of your office or your home Wi-Fi, typically spanning just a few hundred meters. Step up from that, and you get a MAN, a metropolitan area network. These are high-speed networks covering entire blocks or cities, allowing regional resources to be shared, very often using fiber optics. And finally, the whole shebang, the WAN, the wide area network. This covers countries or even the whole world, using massive satellite links and long-distance serial connections. Now, what's really interesting here is that physical scale is only half the story. The way computers actually interact on these networks changes too. Broadly speaking, we have two models. In a peer-to-peer or P2P network, all computers are equal. There's no central boss dictating terms. They share data directly with one another. It's highly decentralized and pretty inexpensive. Contrast that with the client-server model, which, let's be real, dominates most of the modern web. Here, you have clients, like your laptop or your phone, actively requesting information. And then you have powerful central servers acting as the heavy-lifting middlemen that hold and provide that data. Section 3. Speaking the same language. Communication models. So with millions of clients and servers built by totally different manufacturers running completely different operating systems, how do they all talk to each other globally without absolute chaos breaking out? The answer is standardized communication models. These break massive, wildly complex tasks into smaller, manageable layers. On the left, we have the famous OSI reference model, approved as an international standard way back in 1984. It uses 7 very specific layers, ranging from the actual physical wire at the bottom to the application running on your screen at the top. On the right is the TCP/IP suite, which is the more practical four-layer model that actually runs the modern internet. By dividing network functions into layers, each layer only has to worry about its specific job and communicating with the layer directly above or below it. It is essentially a brilliantly organized assembly line for data. So, the absolutely crucial point here is how these protocols actually stack up, which results in this fascinating hourglass shape. Look closely at the narrow center. At the top, you have endless variety, right? Email, web browsers, chat apps. At the bottom, you also have endless physical variety: copper wire, fiber optics, radio waves. But right in that narrow center, acting as the ultimate universal translator, are IP packets. Every single piece of data, no matter where it comes from or where it's going, has to be squeezed through that IP layer. That bottleneck, that is exactly what makes the internet universally compatible. Section 4. Finding your way online. Internet addressing. Okay, so the machines are physically connected, and they're speaking the same language. But how do you actually find anything? Finding specific information on a massive global network requires a highly structured addressing system, and the undisputed hero of this system is the IP address. It is easily one of the most successful technical protocols ever developed. To ensure every single machine on the internet is completely unique, it is assigned a 32-bit number. This is broken down into 4 8-bit fields, or octets, represented by numbers ranging from 0 to 255. It's basically the ultimate digital postal code. Without this unique identifier, delivering a data packet would be like trying to mail a letter to, John on Earth. Good luck with that. But let's face it, we humans are terrible at remembering long strings of random numbers. To solve this, we use URLs, or Uniform Resource Locators. These basically translate messy numbers into human-readable web addresses. And this brilliantly illustrates how a standard URL is logically broken down. First, the protocol, like HTTPS, tells your browser exactly how to transfer the data. Next is the domain name, which is the website's hostname. Then comes the path, which points to a specific folder or directory on that server. And finally, the file name points to the exact document you want to look at, like a specific syllabus.php page. To simplify these abstract web concepts just a bit further, let's use a real-world library analogy. The overall umbrella term is a URI, which identifies a resource. Under that umbrella, you have a URN, which is a globally unique name. Think of a URN exactly like the ISBN number printed on the back of a physical book. It identifies that specific book forever, but it doesn't tell you where to actually find it. A URL, on the other hand, is the specific library location. It tells you to go to the downtown branch, walk up to the 3rd floor, go to aisle 4, and physically pull that book off the shelf. Section 5. Ethics of the network. The human element. So we've covered the history, the cables, the layered protocols, and the addressing. But let's bring this explainer back to the most unpredictable component of all: us, humans. The internet isn't just a bunch of cold machines, it's a society. As the internet has grown from a small academic project into an essential global utility, the need for cyber ethics has become absolutely critical. Being a good digital citizen means adhering to a basic code of responsible behavior. This means respecting privacy and avoiding plagiarism. It means communicating politely without relying on toxic or offensive language. It absolutely requires that we do not impersonate others or digitally trespass into private files. And remember, because the original motivation of the internet was to share resources, it demands that we do so honestly, honoring property rights and copyright along the way. From a small DoD project back in 1969, to a giant network that connects the entire globe today, the internet is just an astonishing achievement in collaboration and engineering. But its future health? Well, that relies entirely on us. So I want to leave you with this final provocative thought. When you log on today, how do your personal daily digital habits contribute to the health and safety of this giant interconnected network? Really think about it. Thanks for joining me on today's Explainer, and I will catch you next time.